Today we're going to be working with missing values in the SAS data step. Let us start out with the definition of a missing value. Missing values are the values that are not available and that would be meaningful for analysis if they were observed. In other words, it is a value that does not exist. However, this does not make them any less important. Missing values appear rather often in clinical trials, so knowing how they work and how to deal with them is very important. Missing values occur in clinical trials for a number of reasons. The company that sponsored the trial, or the investigators, could have simply not planned the procedure well. They could have also been careless about how they collected the data, possibly overlooking some things. Another cause could be that the subjects of the trials were unavailable when they needed to be tested, or they could have withdrawn their consent and discontinued the study prematurely. Another possibility is that the investigational medicinal product, the drug being tested, could have also caused an adverse event that prevented the collection of certain pieces of data. Another reason is a third party, such as scientists at a lab charged with analyzing samples, could have been careless and maybe lost samples meant for analysis. There are many different possible reasons for a missing value, which is why they appear so often in clinical trials. This makes it necessary to know how to deal with them when they show up in your data. There are many different ways to represent missing values in raw data, depending on what type of value it was. A numeric missing value is displayed as a period, while a character missing value is displayed as a blank enclosed in quotation marks. There are also special missing values, but they are only used for numeric variables. These special missing values can be expressed as a period with a letter or as a period with an underscore. Now we'll go over how to set variable values to missing values. Sometimes data comes with variables containing values that do not make any sense, such as in this dataset called student. The values for the variable score1 are all negative, which does not make any sense. One of the values for the variable name is none, which also does not make any sense. This could be due to incorrect data entry. Otherwise, changing the nonsensical values here to missing values would be appropriate. On the left side of the screen, you can see the syntax used to do this. A new dataset is created called student A, which is a set of the original dataset student. An if-then statement is then used to find all values of the variable score1 that are less than 0, and then setting those values to a missing values. Another if-then statement is then used to find when the variable name has the value none, and then setting that value to a missing value as well. The printout for the original dataset student would look like the chart in the upper right. It still has the negative values for scores. However, the printout for the dataset student A in the lower right has missing values in place of the negative numbers and the name none. Now we'll go over setting values to missing with the missing statement. Before, we were setting conditions on entire variables to set any value under that variable that meets those conditions to a missing value. You can also convert individual values in this dataset, called student B, into missing values using the missing statement. Here, the syntax includes a missing statement within the data step. The missing statement is then followed by the values that you want to become missing values. Printing student B will then result in the upper right chart. Furthermore, you can do the reverse. Convert missing values into non-missing values. Create a new dataset called student C by using the set statement with the dataset student B. Use the if-then statement to find when the variable score1 is the special missing value .a, and then set score1 to be 67. The resulting printout is on the bottom right. Notice how missing values are not case sensitive. Now we'll be setting values to missing with blank input. SAS sometimes recognizes a blank space as a missing value. When entering the data manually into SAS, simply leave a spot blank for the syntax. The printout should come out like the one in the upper right. As you can see, the blank spaces were interpreted as missing values. The missing character value under the variable name is denoted by a blank space, and the missing numeric value under the variable score1 is denoted by a period. Now we'll go over the missing statement and invalid data. If you have the dataset student D, and it uses the missing statement we described previously that is followed by the values A, B, C, D, and E, while the dataset student D has values A, B, C, D, and F, you will get an error message. The comment below the code in blue is what would appear in the log if you ran this program. The problem is that the variable score1 is numeric. All of score1's values are letters. However, A, B, C, and D are all considered to be missing values due to the missing statement. F, on the other hand, is not part of the missing statement, and since F is not a numeric value, it comes out as an error and is displayed as a missing value in the printout, but with a period instead of a special character missing value. Now we're going to talk about setting values to missing with the call missing routine. Using the call missing routine, you can make all values of certain variables into missing values. This is different from what we did before with the conditionals, since this is setting every value within a variable to a missing value. Using the dataset student E, create another dataset called student F using the set statement. Then use the call missing routine and put in parentheses the variables whose values you want to make missing. Here, as you can see, the syntax within the parentheses say name, of score1 score3. This will make all of the variables from the original data into missing values. You can rewrite the of score1 score3 into score1, score2, score3. The former method is simply another way to list them. You can see the results of the call missing routine on the bottom right, or rather the lack of them, since everything was made into a missing value. The character variable names values were all made into character missing values, and the numeric variables score1, score2, and score3 had all of their values made into numeric missing values. Now we will talk about setting missing numeric values using system options. Using the options step, you can have SAS make every numeric missing value into a special character of your choosing, rather than the default period. Simply start the program with the options step, follow it with missing equals, then type what you want to replace the numeric missing values by. The example chose to use B to replace all of the missing values, and the results are shown in the upper right. As you can see, instead of denoting the missing values with a period, SAS denotes them with the specified character B. Be aware that this does not apply to special missing values such as .a. Those special missing values will still appear as their corresponding special character. Now we'll talk about the sorting order of missing numeric values. Missing numeric values can be sorted just like other values. The syntax is exactly the same as the syntax used for sorting non-missing values, but the order missing values are sorted in is underscore first, period second, then the letters in alphabetical order. The upper right printout is before the sort, and the lower right printout is after the sort. Now we're going to talk about missing values in assignment statements. Generally, computations involving missing values result in missing values, as a missing value is not a number. We'll talk more about this later. Computations include the various operations such as plus, minus, multiply, and divide. This is one case of how missing values can mess up your algorithms. In this example, we are trying to take the average of the three scores by adding them up and dividing that sum by 3. If you ran this program, the SAS log would say this note here: missing values were generated as a result of performing an operation on missing values. So this program unfortunately only worked for the first observation, Smith, because none of Smith's scores were missing. Every other observation had at least one missing value, making the average a missing value. However, there is a way to easily calculate averages with missing values. Now it's time for us to learn how to average data using non-missing values only. The problem with the method from last slide was that it had to use all 3 values, whether they were missing or not. By using the mean function, you can calculate the average using only values that are not missing. This allows for an average to be calculated for all of the observations. As the example shows, simply use the mean function and in parentheses list the variables that you want to average. Note that you can rewrite the variables score1, score2, score3 as of score1 dash score3. If one of the listed variables has a missing value, then the mean function will disregard it and take the average using only the non-missing values. Now we're going to talk about checking for missing values using the missing function. If you have a large dataset and you do not want to read through every single cell to find missing values, you can check for missing values within a row using the missing function in conjunction with if-then conditionals and logic statements such as not. The meaning of the syntax on the page is: if the variable score1 is not missing, and the variable score2 is not missing, and the variable score3 is not missing, then find the average of the 3 variables by dividing their sum by 3. Since there is no else statement specifying what happens if one of the variables is missing, it simply results in a missing value. What the missing function does is check whether or not there is a missing value within a character or numeric expression. This is useful for identifying which observations contain missing values. Now we're going to be checking for missing values using the n function. Another way to check for missing values in an observation is by using the n function. This function counts how many non-missing numeric values there are in a listed set of numeric variables. For example, the n function used in the syntax here checks for the number of non-missing values among the 3 variables. The entire code comes out to mean if the number of non-missing values among the variables score1, score2, and score3 is 3, then take the average of the 3 values. Remember, this only works for numeric values, and a numeric expression is considered missing if it results in a missing value, so it can be a period, dot underscore, dot a, dot b, etc. Similarly, now we're going to be checking for missing values using the nmiss function. This function works exactly the same as the n function described last slide, except the nmiss function counts how many of the values are missing, contrary to how the n function counts how many values are not missing. The syntaxes are almost identical, and the results are exactly the same. Now we're going to be talking about missing values in logical statements. Previously, we talked about how missing values are not numbers, so they generally have a hard time when plugged into computations. However, they are still considered to be extremely negative numbers, or negative infinity. Take for example, you have an if-then-else statement saying something like, if score1 less than or equal to 75, then flag equals 0. Else flag equals 1. Since missing values are considered to be negative infinity, a missing value will fit the condition stated. This is not always favorable, since in many situations you do not want to interpret missing values the same way you interpret non-missing values. you would have to somehow create a condition that explicitly excludes missing values in order to avoid this situation. Luckily, there is a way to do that. Now we'll talk about how to exclude missing values in logical statements. There's a very simple way to create a condition to exclude missing values. First, start the code off with saying, if score1 less than or equal to .z, then flag equals period. This checks if score1 is missing, and if it is, then flag is missing too. This is followed by else if .z less than score1 less than or equal to 75, then flag equals 0. This gives the condition for setting flag to be equal to 0 by binding the condition on two sides. It makes sure that score1 is less than or equal to 75, and that it is greater than a missing value. In other words, greater than negative infinity. There is also a reason why the lower boundary is .z instead of just a period. It is that if you only said if score1 equals period, then it would not check if score1 was any missing value. It would check if score1 was a missing value represented by a period. If score1 was a .a, .s, or any of the special missing values, flag would have been marked as 0 instead of missing. Saying less than or equal to .z checks if score1 is any of the numeric or special missing characters. Now we'll talk about what happens when you convert a missing number into a character value. There's a way to convert missing numeric data into character data. This is done through the put function. Using the syntax in the left box should get it to work. But the weird thing is, when converting missing numeric data into character data, it will not produce another missing value. It will instead just convert it into character data. But there is a way to go about this. In order to do so, we'll be converting a missing number to character with the missing function instead. We'll be using the missing function again in order to check if the variable is missing. As seen in the syntax in the left box, if not missing score1, then score1c equal put score1 comma best2 dot. Makes it so that SAS only converts the non-missing numeric data into character data. By default, SAS will then take any observations of score1 that were missing and make them missing for score1c too. Now we will be talking about how to use where statement is null. Using the where statement and is null, you can check for where the variable is missing. In this example on the left, a new dataset, student H3, was created from the original dataset student H. Student H3 only existed where the variable score1 was not missing. Since score1 was always missing in student H3 has no observations. So we have gone over special missing values, but we have not really discussed why would we want to use them. They are actually very useful for labeling and distinguishing between different types of missing values. In clinical studies, missing values occur for multiple different reasons as discussed earlier. Assigning a special missing value to each of these can be helpful for analysis, since it will be easier to distinguish between the different types of missing values, and people can possibly identify a pattern among the missing values for further analysis. Now, to summarize numeric missing values. To input numeric missing values, there's a period and the 27 special missing values, and sometimes a blank space, which can be used to denote a missing value. These are all case insensitive. To set missing values to a special character, you can use the missing systems option. However, beware that the missing systems option does not work on special values. In logical statements, missing values are also case insensitive. It is easy to check for all possible missing values with the logic statement less than or equal to .z following an if statement. In the output, missing values are displayed as a single character. Letter values are always uppercase. If the missing system option was used, then all periods will be displayed as whatever character was set by the missing systems option. Finally, there are also these things called missing value assumptions. These are just things to think about when working with missing values. Generally pay close attention to the log to make sure you are not accidentally creating or losing missing values. The result of any operation on missing values will result in a missing value. Finally, even if a variable should not have any missing values, write your code under the assumption that there may be missing values. Make sure to experiment with your programs, and if you have any questions, feel free to ask a more experienced SAS programmer. And of course, thanks for watching.